Aneel Lakhani has deep insights into this observability thing that I think you can only get if you've spent enough time in our industry digging into stuff to start to figure out what is going to help you and what is really, really not. So without further ado, I'm going to give the stage to Aneel Lakhani. Give it up for Aneel.
As I awkwardly walk, oh, is this on? It is on. Hello. Thank you for everybody who's still alive in here. I have a nice coffee. This is normal for me. If I didn't have one, you should be worried. All right, so I know what I'm supposed to do is have a talk that has a lot of funny pictures and a lot of funny stories. But what I'm going to have is a talk that has a lot of words. There are going to be words on the slides. There are going to be words coming out of my face. You can pay attention to either, or neither if you like. If you find it boring, I'm sure Jesse's talk will be fascinating later. But I kind of key in on information more than I used to. And I've been, that's me. I'm sure it was self-evident which one of those dudes was me. I'm not as old as Brian Lyles, if he's still in here. But I've been around since 9600 baud was normal and what everyone had. So that doesn't necessarily make me old as much as it makes me cranky. I am very cranky. Brief non sequiturs. This is my boss, Charity Major. She says hi. She's unable to be here today. This is Sasha Bates, who many of you might know if you've been here for a long time. She also says hi. I talked to her last week. All right, so what am I discussing? How many people here have heard the term observability before? Oh, that's a lot of hands. Okay. So for the ones who haven't, presumably you've heard the words monitoring, logging, metrics, exceptions, traces, profiling, timers. Yeah, okay, nodding heads. Good, great. This is going to be easy. So observability is, the term comes from control theory. Do people know what control theory is? Yeah, math, physics. Hey, how you doing? If anyone's ever been in a nuclear program, this will make perfect sense. Yeah, so control theory is you get information and then you make decisions and then you control some system based on the information and decisions. So technically speaking, observability is when you can have information about the system sufficient to make a decision. A less formal version is that you can figure out what your entire system is doing, whatever your entire system is. I mean, your entire system might be, you know, one VM, or your entire system might be 10,000 machines over 6 colos running 10 services or something. But you can figure out what the entire system is doing, what its state is, based on the outputs coming out of it. Now, Sam Stokes was the white guy in that picture earlier, who works with me, says that observability is two things. It is both that the system is observable, so it is producing outputs that let you figure out what it's doing, one, and two, that you actually can observe it. It's not sufficient that the system provides outputs. You also must be able to consume those outputs and figure out what the system is doing. So if the system provides outputs, but you don't observe it, you don't have observability. What you have is a system providing outputs. If you're observing nothing, or if you're observing shit outputs, the system still does not have observability because you're just consuming useless information. So you need both ends of this. I add a little something when I talk about this, which is the bit about shit outputs, right? So you must get sufficient understanding out of your observability setup and your observability system to make a decision, right? To make a decision that is furthering your ends, whatever those are. And those are usually one of three things. Either you want to do more observation and go look at something else, so you're doing investigation or triage or root cause analysis of some kind. Or you're going to take a remediation action because you figured out what the problem is. Or you're just doing improvement, right? You're tuning a system, you're profiling to figure out how to get more performance out of a particular code path, whatever. You're doing one of those things. If you don't get sufficient understanding of your system to do one of those things, you have not actually achieved observability. You're just messing around. So why should you care? Not everybody does care. I don't necessarily know that everyone should care. I care because I've been doing this for a long time. But if you operate software or hardware or systems of any kind, If you have observability, you know what it looks like when a thing is doing what it's supposed to be doing, right? And like, you know what it looks like when someone is learning how to ride their bicycle, when they're pedaling in a way that's going to achieve riding their bicycle versus falling on their face. And you know what it looks like when a thing is not doing what it's supposed to be doing. And you need both of these. You can ask questions, you can get answers. But if you can't get answers, you can figure out how to get answers by changing what you're doing or adding instrumentation or creating more data in order to answer those questions. If you can't do all those things, then you're not going to be very successful. When you don't have observability, you can't tell the difference between normal and abnormal. You know, you can't tell that your systems are going to fall over when they are going to fall over. You can't figure out whether problems are internal to you or external to you. So what constitutes observability? So it is not any of these things. There are an infinity of vendors who will sell you one or some combination of these things and tell you that you have achieved observability. None of these things constitute observability. They're all good to have. Altogether, you might achieve observability, but none of these things are that. Go. Go. Oh. I have a problem. There we go. OK. So the way I like to think about it is that observability constitutes three things. One is instrumentation, right? Something happened, and you produced information that that thing happened. Every single time something happens, you produce information. Second is transportation. So remember Sam's definition, you have observability as a property of the system, but observability as something you do, and you need both of those things. So something happens, you create information, you have to send that information somewhere, and that somewhere is where you do the observation part. If you do not have these three things, you have not achieved observability. So let's talk about each of them a little bit. So instrumentation, the way I look at it is, the word I use is a scaffolding, because any number of things constitute instrumentation. Instrumentation could be an SDK for some monitoring product that allows you to increment a counter every time someone logs in to your service. Instrumentation could be generating a log line every single time a particular code path gets stripped. Instrumentation could be pinging a thing to see if it's up, or an HTTP status check to make sure you get a 200. Instrumentation is anything that produces information about the event. I tend to split instrumentation up and the information it generates into two kinds of things. One is telemetry and one is events. So telemetry is what a lot of people are used to. Telemetry is metrics, counters, gauges. It's a stat of some kind. A timer may or may not, like people can argue about whether a timer constitutes telemetry. But it's a stat that tells you something about the state of a system, right? What the current state is, what the change in the state has been, or how long you've spent in a state. Usually these things are numeric. Usually they come with some amount of context in the form of tags or dimensions, as you're all familiar with if you've used monitoring products or APM tools. And then the other item is events. And an event is the actual thing that happened. So the way I look at it is that telemetry gives you the result of an event or some measurement of the output of an event, right? 10,000 people logged in. So that's 10,000 individual login events, which generates a number that's 10,000 logins. But the events are the actual individual 10,000 logins. No. Yes. No. Aha. And then you have transportation. So transportation isn't just getting a bit of data from point A to point B. There's how you encode the data. I'm leaving out protocols and wire, what it looks like on the wire, just for clarity, but also how you transmit it. So typical forms that observability data takes, that this information takes, is metrics, logs, traces, sometimes just structured JSON, SSF. If you've never heard of it, look it up. It's really cool. And then you transmit it somewhere. And the way you transmit it could just be to a terminal and you look at it with your eyeballs. That's a legit method of observing something. Or it goes into message queue or some kind of data pipeline and ends up somewhere. And then observation is, well, I mean, it is what it sounds like, right? You're doing the observing, or some machine is doing the observing. So this takes all kinds of forms. People whose whole universe of discourse is just dealing with unstructured text, they just search logs, which is fine. I don't think it's the best way of doing things, but it works. And then you have all kinds of other mathematical operations you can run, aggregations, filtering, et cetera. And any interface is legit, right? You look in a terminal, you look in a log aggregator, you throw stuff into a time series database and layer a GUI on top of it that can draw you some charts. There's an infinity of these things, but they all work. So there is no one way. This is going to be a super fast talk because I'm going at twice speed, I think. There is no one tool, even though I work at a vendor that does observability. There is no one tool. There's only your way. There's only your tool chain, and everyone has to pick one. And it should do all of these things, right? You do actually need metrics, right? You do actually need to do aggregations. You do actually need to look at events if you're doing forensic analysis or if you're trying to figure out the exact source of a problem. You do actually need error handling and exception handling. You do actually need to run checks, especially for black box monitoring. You need to know whether a thing is up or down from an external perspective. You need to know whether it's responding with the right status codes from an external perspective. You need to know that your API is responding the way it should, given all the various cases in which it should respond. If you're trying to optimize a particular code path, you do actually need to do profiling. You do actually need to run traces if you're running a distributed system. You do actually need to find out how long it takes from the point in time that someone initiates an action until they get the final response they want, and how long it takes through all the 20, 30, however many services you have to do that. You actually need all of these things. There's no one tool for all of these things, which means you need a tool chain, which all of you know because all of you have multiple tools to do all of these things, and none of you rely on one tool, which as someone who's been both on the buying side and on the selling side of tools for this equation for 20-ish years now, it baffles me every day that people really, really want to have one tool. You're not going to have one tool. It's not going to happen. Give up. Get used to reality. and every vendor you speak to and you're like, oh, I want to remove these 3 things and replace them with you. It's going to suck. You can do that. It's going to suck. Which means, yes, you do need to track system stats, CPU stats, I/O stats. You do need to know that people are logging in, where are they logging in from, and what are all the individual events that happen during the execution of your service. You do need to know things like build fails, kernel panics, there are exceptions. You do need to run these external checks. You do need to also listen to users. Users are part of your observability. If you have users, presumably you have users, or someone is going to complain to you when something's not working. That someone is part of your observability system. Your ticketing system is part of your observability system. Your first-line customer support, your lab techs that get escalated to, those are all part of your observability system. And those are all inputs into you understanding how your system behaves, how it behaves when it's working correctly and how it behaves when it's not working correctly. I will say that you also, so I didn't know where to put timers because it was inconvenient to try to figure out where to fit it in here, and I didn't want to ruin the symmetry of the slide. But you should be tracking the time of everything, right? You know, not just when you're doing profiling and seeing the code path, and not just when you're, taking traces, but also in general, how long does it take for all of the responses to all the things that you're trying to figure out, which includes your customer support people responding to user input. Okay. So regardless of the tools you use, and regardless of the things you track, and regardless of how you construct your systems, the one thing I will say that everyone should do and think about and have to do is provide as much context as possible. How many people have been around since Tivoli early days? Oh yeah, Minneapolis is great, bunch of old people. I worked at IBM a long time ago. Right, so in the days when we use words like event correlation analysis and ECA as the acronym, and all the similar tools around that area, tracking context, like the full context, like the execution stack of a particular call, or the complete trace of a transaction was expensive because hardware was expensive. And storing all that information was expensive, and you couldn't store it forever, which meant you eventually threw it out. That has become less and less true over time, which means we are able to keep more and more context about every event, every transaction, every last little thing that happens in our system. Insofar as you can afford to do that, you should do that, because that is what enables you to figure out with better fidelity what is going on and how you might fix it in a faster time period. So Charity has a rant about how metrics lose context. And if you look at modern metric systems, you'll notice that they've steadily been adding context back in by adding the concept of tags or dimensions or what have you. And this is a good thing because more context is better. Event systems like Honeycomb are designed with context in mind in the first place. And I don't really care what you use, but whatever you use, don't use things that don't allow you to add a lot of context. So context is what lets you answer these questions, and these questions are important, right? Service is down, well, which service? Which machines? Which cluster? Which users are impacted? Which API endpoint? What shards? What's the duration? What's the severity level? Which deploy number is correlated with this? What SDK version is the person on? What OS version? What's the endpoint? Are they on a mobile device? Are they on a phone or an iPad, or are they in Africa? The more information you can have, and the more the things you choose to use enable you to have information, the better decisions you can make. So let's provide an actual example. That little person on the bottom left, that's Mark McBride. He wrote this example. All credit to him. So if we start counterclockwise from the top left, you can have an event that says, something happened, right? Let's go to the next one down, bottom left. All right, this is a little better. So we know that whatever something is that happened, it happened in East 1A. And there's a host, and service dog picks version 1.0 of the API, and there's the API endpoint. And those are parameters, and our message still sucks. We should come up with better messages, but oops, fine. At least now we know where to look. But if you're able, what you should do is this, right? On top of what's happened, I also know everything about the user impacted. I can look stuff up by the user ID. If I know their user ID, I can go see what they did before, what they did after, what their whole context of operation is, and see what other systems they touch, and then go look for other people who look the same or who have the same pattern of behavior or same pattern of experience. That's how you actually get to solving a problem. So Sam says this. You have to build observable systems. I'll actually take it a step further. You have to use observable systems, right? So if you own the code and it's your code, you can add timers and throw exceptions or whatever. So you totally control the observability of that system if it's your code. If you're using open source software, you will tend to treat it like off-the-shelf software, because most people do tend to treat it like off-the-shelf software, unless you really dedicate effort to customizing it. But most open source code has some amount of observability built into it, or there are agents, or there's some method of generating log lines, or some method of collecting metrics or outputting events. But I will go a step further and say that you should use off-the-shelf software that is observable, right? So if you're using commercial off-the-shelf software and it does not generate output, it does not generate observable information, which you can pipe into the tools that you use, don't use that software. Don't operate that software, or try not to, or push back against operating it. Especially if that software provides observability data in a proprietary format that goes into a proprietary system, which you have to use only for the operation of that software. Resist. Resist as hard as you can, right? Best case scenario is that everything that you run, you can observe, and you can observe it in as few silos as possible. I'm not saying it's possible to eliminate all silos, but you should be able to eliminate some. Yeah, if all something is doing internally is generating log lines and piping it into a custom log aggregator that you can only use it and not any other kind of log aggregator, that's crap. Fire those people. So build observable systems. It'll get you where you're going. Is there a Cheslock in here? No? Okay. Well, it'll get you where you're going. Okay. I have no idea how fast I was, but thank you. Try Honeycomb. It's free. We want all the feedback we can get. We have a free trial. We want people to bang on it. We want people to tell us why it sucks so we can make it better. And read things. Please read things. Don't take my word for any of this. Go read these things. I will tell you why. So that letter from John Allspaw complains about how we're building all of these tools wrong, and he's right. Sam's post about building observable systems really walks you through the point of how you get to an observable system. Cindy's post on logs versus metrics is excellent. It is an excellent, especially because it kind of, and I have a rant about the differentiation between how you encode information and the information that you're encoding. Cindy does a good job of talking about this, right? Because what we're actually encoding is things that happened, and how we encode them is kind of irrelevant, right? You encode that in a log or a metric or whatever. However you choose to encode that is irrelevant as long as you get the context you need out of it to make a decision. Mark's post walks you through how he generated that example and what the use case is for that. Ben's, that's a video, so it's not reading material, but it's worth watching. It's his keynote from SRECon 14, where he actually talks through the principles of SRE, and you'll note that a significant portion of that is the act of observability. And simple sensor format, if anyone hasn't heard of it, was mentioned in Monterama earlier this year. It basically provides a single data model for metrics, traces, logs, and every kind of observability information there is. And then finally, the academic part, Wikipedia observability. All right. Yay.